Okay, here we are for lesson 9, conditions for a unique triangle, 3 sides and 2 sides and the included angle. So if you notice from our review, there are different types of triangles. Well, how can we decide what is a unique triangle? If all we're given are some simple characteristics, do we have unique triangles or can we draw triangles that are different? So that's kind of what we're looking at for this lesson. What you're going to need before we get started is a ruler with centimeter markings, a protractor, a compass, and a couple of sheets of blank paper. Alright, for our opening, we have learned that triangles are identical if there is a correspondence between the triangles that matches sides of equal sides and matches angles of equal measurement. What conditions on a triangle always produce identical triangles? In other words, what conditions on a triangle determine a unique triangle? So given a triangle, we consider conditions on the triangle such as the measurements of the angles, the measurements of the sides, and the relationship between those angles and sides. So if we measure all of the angles and sides and give all of the relationships between the angles and sides, then any other triangle satisfying the same conditions will be identical to our given triangle. If we give too few conditions on a triangle, such as the length of one side and the measurement of one angle, then there will be many non-identical angles that satisfy the conditions. Sometimes just a few specific conditions on a triangle make it so that every triangle satisfying those conditions is identical to the given triangle. In this case, we say the conditions on the triangle determine a unique triangle. That is, all triangles created using those conditions will be identical. Alright, so let's try this exploratory challenge. A triangle, XYZ, exists with side lengths of the segments below. Draw a triangle, X prime, Y prime, Z prime, with the same side lengths as triangle XYZ. Use your compass to determine the sides of triangle X prime, Y prime, Z prime, and use your ruler to measure the side lengths. Leave all construction marks as evidence of your work, and label all side and angle measurements. So under what condition is triangle X prime, Y prime, Z prime drawn? Compare the triangle you drew to 2 of your peers' triangles when we get back to class. Are the triangles identical? Did the condition determine a unique triangle? Use your construction to explain why, and do the results differ from your predictions? So first, make a prediction. Write down your prediction about how many different triangles can be generated under this set of conditions. That is, 3 different line lengths. Using the line lengths, the ruler and the compass, draw the triangle. So using our compass, we would draw circles using the line lengths of 3 centimeters for the radius for the first circle, and then the radius for the second circle, and then that would also be the length of the horizontal line on the bottom. You will compare your drawing in class. So describe how you drew your triangle using the appropriate vocabulary. The condition on triangle X prime, Y prime, Z prime is the 3 side lengths. All the triangles are identical. The condition determined a unique triangle. After drawing the longest side length, I use the compass to locate the 3rd vertex of the triangle by drawing 2 circles, one with the radius of the smallest side length and the other with the radius of the medium side length. Each circle was centered at one end of the longest side length. 2 possible locations were determined by the intersection of the circles, but both determine the same triangle. One is just a flipped version of the other. The 3 side conditions determine a unique triangle. Alright, for number 2, triangle ABC is located below. Copy the sides of the triangle to create triangle A prime, B prime, C prime. Use your compass to determine the sides of triangle A prime, B prime, C prime, and use your ruler to measure the side lengths. Leave all construction marks as evidence of your work, and label all side and angle measurements. So under what condition is triangle A prime, B prime, C prime drawn? Compare the triangle you drew to two of your peers' triangles when we get to class. Are the triangles identical? Did the condition determine a unique triangle? Use your construction to explain why. So, if you take the side lengths from AB, AC, and CB, you would notice that CB or BC is the longest length. So we use that as our starting line segment. Then from angle point B, if you measure B to A, that is 2.6 centimeters, and draw a circle. Then measure the medium side length from point C and draw that circle. Go ahead and measure those two side lengths, and you would have had 2.6 centimeters and 4.2 centimeters. And then as you measure the angles, you would determine that angle B is about 49 degrees, angle C is 29 degrees, and angle A is 102 degrees. So the condition on triangle A prime, B prime, C prime is the three side lengths. All the triangles are identical. The condition determined a unique triangle. After drawing the longest side length, I use a compass to locate the third vertex of the triangle by drawing the two circles, one with the radius of the smallest side length and the other with the radius of the medium side length. Each circle was centered at one end of the longest side length. Two possible locations were determined by the intersection of the circles, but both determine the same triangle. One is just a flipped version of the other. The three side conditions determine a unique triangle. So for the third one, a triangle DEF has an angle of 40 degrees adjacent to the side lengths of 4 centimeters and 7 centimeters. Construct triangle D prime, E prime, F prime with the side lengths of D prime, E prime is 4 centimeters and D prime, F prime is 7 centimeters, and the included angle of D prime, which is 40 degrees. Use your compass to draw the side lengths of triangle D prime, E prime, F prime. Use your ruler to measure the side lengths. Leave all construction marks as evidence of your work, and label all the side and angle measurements. So under what condition is triangle D prime, E prime, F prime drawn? Compare the triangle you drew to two of your peers' triangles when we get to class. Did the condition determine a unique triangle? Use your construction to explain why. Alright, so here's what we're given on our paper. So let's go ahead and take a look at how we would do this if we're given an angle. Alright, so I've copied you have this on your lesson worksheet, but I've copied it here on my blank piece of paper. So if we've measured 40 degrees from here, then what I'm going to do is measure it from over here. So notice that if I have D, I'm going to make this 7 centimeters. You can do this one of two ways. We can go ahead and draw a line if you want. That is going to be 7 centimeters. And we'll just draw a line for right now and we'll measure it later. But taking our compass, we use our compass to measure between D and F because we want to start with our longest side. So once we've moved that, now we use our D and we make an arc mark. And it just so happens that I made mine about 7 centimeters. If for some reason your line was longer, that's completely fine. So we're concerned with right here, this is going to be F, and we know from our compass that this is going to be 7 centimeters. Alright, so how do I know that this is going to be 40 degrees? Well, going back and marking that this is going to be 40 degrees, put the vertex and mark at 40. All right, so here is 40 degrees, and I'm going to go ahead and draw a line. Now again, I'm going to make it longer than what is needed, but that's okay. Now we know that this is 40 degrees. So we have our 7 centimeter line drawn with our compass and marked with an arc mark, and we've used our protractor to make our 40 degree angle. Now let's go back and measure, using our compass, the segment D to E. So here we go, using this to spread it out, and then using point D and the compass, we mark the intersection. So here is E. All right, now that we have point E and point F, we can just use a straight edge to draw a line that connects these two. And this is line segment EF. So now they've asked us to measure these. Well, let's double check. So here is 7 centimeters. Here is 4 centimeters, and we'll go ahead and label this. And so now what is the length of your line segment from E to F? And it looks like it's about 5 centimeters. So now check that with, we'll check these with other people when we get back to class, but you should all have the same thing. And we estimated 5 centimeters. The actual length should be about 4 centimeters, or 4 7/10 of a centimeter. Now we can also go back and check the angle marks, or the angle measurements, which we didn't do, but let's go ahead and do that. So let's see if we do have about 107 degrees. So if we take this and put E at the vertex and line segment DE is at 0, then you're right, this is about 107 degrees, because here is 110. We're between 100 and 110. So it would make sense that this is about 107 degrees. Now on the answer key it said that angle F was 33, so let's check that. Put our protractor and look at the line going through. It's between 30 and 40. So yeah, it's almost 33 degrees if we were to measure this out. So that would make sense, because 107 and 33 is 140, and then plus 40 would be 180. And we know that all triangles have 180 degrees. So we should have the same thing. We're given 2 side lengths and an included angle, and we end up with the same triangle, and when we get back to class you'll see that everybody will have the same one drawn. So the condition on triangle D prime E prime F prime is 2 side lengths and the included angle measurement. All of our triangles are going to be identical. The condition determine a unique triangle. Once the 40 degree angle is drawn and the 4 centimeters and 7 centimeter side lengths are marked off on the rays of the angle, there is only one place the third side of the triangle can be. Therefore, all triangles drawn under this condition will be identical. Switching the 4 centimeters and 7 meter sides also gives us a triangle satisfying the conditions, but it's just a flipped version of the other. So going back to this triangle here, if we made this side length 7 and this side length 4, we would still have about 5 centimeters in between. It's just the orientation of this triangle would be different. All right, so you're going to try this with number 4. Triangle XYZ has side lengths of 2.5 centimeters and Y is 4 centimeters. And the angle X is 120 degrees. Draw a triangle X prime, Y prime, Z prime under the same conditions. Use your compass and protractor to draw the sides of triangle x prime, y prime, z prime. Use your ruler to measure the side lengths. Leave all construction marks as evidence of your work and label all side and angle measurements. So under what condition is triangle x prime, y prime, z prime drawn? Compare the triangle you drew to two of your table mates' triangles when we get back to class. Are the triangles identical? Did the condition determine a unique triangle? Use your construction to explain why. So depending on how you drew this, you should have something that looks like this. And then pause the video to read and edit your response as to how you describe this. Remember, all of these descriptions are basically the same. They have the same information in basically the same order, so you should recognize a pattern of how to answer these. All right, so you should be done with this problem. So let's go ahead and discuss. You can take notes in your journal. So write down anything that is important for you to refer back to. One of the conditions we saw in Lesson 8 provided two angles and a side by which a maximum of 3 non-identical triangles could be drawn. Today we saw that two sides and an included angle determine a single unique triangle. What differences exist between these two sets of conditions? Well, the condition from Lesson 8, 2 angles and a side, involves different parts of a triangle from the condition in Lesson 9. 2 sides and an angle. Furthermore, the conditions in Lesson 9 also have a specific arrangement. The angle is specified to be between the sides, while there was no specification for the arrangement of the parts in the condition from Lesson 8. So does the arrangement of the parts play a role in determining whether provided conditions determine a unique triangle? Well, it seems like it might, but we will have to test out other pieces and other arrangements to be sure. All right, so to wrap this up, by drawing triangles under the 3-side condition and the 2-side and an included angle condition, we saw that there is only one way to draw triangles under each of the conditions, which determines a unique triangle. The term diagonal is used for several problem set questions. Expect this and review the definition provided in the lesson summary. That has been included right here. So the following conditions determine a unique triangle: 3 sides or 2 sides and an included angle. So in the quadrilateral ABCD, the segments AC and BD are called the diagonals of the quadrilateral. Notice that they make triangles if you split these up. All right, we'll see you in class.